I'm excited to look at this problem with you guys. It is a fun one. This is number 5 in Achieve section 7.6. It gives us the integral of the natural log of, yours will be slightly different more than likely, but the natural log of x to the 4th minus 256. Of course, we're integrating it with respect to x. As soon as you see a natural log in there, you automatically know that this is going to be an integration by parts problem. So we let u equal the entire log function, and then you know that the derivative of that, derivative of any log, is 1 over what's inside the log, and then the numerator is always the derivative of what's inside the log, and then we know we're taking this derivative with respect to x. So we get 4x cubed over x to the 4th minus 256 dx. Now, dv has to be the dx in the problem, and so the integral of 1 dx is just x. Now I say, okay, so far my integration by parts tells me that my answer is going to be the u times v, x, natural log of x to the 4th minus 256, minus the integral of v du. So in this step, I know that this v is going to be multiplying this numerator inside the integral. I went ahead and factored out the constant factor of 4 out front. So I have minus 4 times the integral x to the 4th over x to the 4th minus 256. Now, I knew this part was already done, but this part's going to require some more work. So that's why I put this. Now we must work the integral of x to the 4th over x to the 4th minus 256. And what you're supposed to remember here is that anytime the degree of the numerator and denominator are the same, or anytime the numerator is the same or greater degree, you have to use long division. So I divide that denominator into the numerator. Clearly x to the 4th only goes into x to the 4th one time. 1 times x to the 4th minus 256 is x to the 4th minus 256. But be careful you don't make a sign error there. We have to subtract that out. The x to the 4ths cancel, and we're left with a positive 256. Okay, so now I go back to my problem and I say, well, then this portion of the problem is equal to the part that divided out. It's just the integral of 1 with respect to x. That's very easy. That's just going to be an x, and later on it gets multiplied by the 4 and becomes the minus 4x, and our answer way down here. But now, to the other part. We say, well, you had a remainder of 256, so that 256 would be left inside divided by this denominator. Now, I automatically knew as soon as that numerator was lower power than the denominator, it would help if I get that denominator factored. So I've done two things here. I went ahead and factored the 256 out and just said I'll just have a 1 left inside the numerator. And then that denominator. I recognize 256 is nothing more than 4 to the 4th power. So I can say, well, then that is x to the 4th minus 4 to the 4th, which is going to factor to be x squared plus 4 squared, or x squared plus 16. And then the x squared minus 4 squared becomes x plus 4, x minus 4. So it factors by difference of 2 squares twice. And so I know this is the fully factored final form of that x to the 4th minus 256. And I can say, okay, now I have my denominator as a product of 2 linear factors and 1 irreducible quadratic. So then I had to rewrite the fraction on the inside. My goal was to rewrite this fraction into 3 simpler fractions that would be integrable. So I know that over the irreducible quadratic factor, I have to have a linear numerator of ax plus b. Over the factor x plus 4, I have a linear numerator of c, and over x minus 4, I have the linear factor d. I set up my problem and say, okay, now I need to get rid of this denominator, so I multiply by all 3 of these factors throughout the entire equation. Clearly on the left-hand side, you have a 1. On the right, you would have ax plus b times the other 2 factors. Obviously, the x squared plus 16 would cancel out. You have c times the other 2 factors, x squared plus 16 and x minus 4. And you have d times the other 2 factors of x squared plus 16 and x plus 4. The x minus 4 would cancel. Now I'm left trying to figure out what are a, b, c, and d. Anytime you can make any of the denominators equal to 0, it's going to enable you to solve for a variable. So the first thing I did is I said, well, I can probably solve for c by letting x equal -4. If I let x equal -4, nothing happens to the left side of your equation. It's just a constant of 1. But if I let x equal -4 on the right-hand side, then any of these products that has x plus 4 as a factor becomes 0. So you'll see the first group becomes 0, the last group becomes 0. My only group that doesn't become 0 is the middle one with the c. So I would say c times -4 squared. That's 16 plus 16 is 32. -4 minus 4, -8. I have c times 32 times -8. That's a -256c, and I know that that has to equal 1. Therefore, I know c is -1 over 256. Now I need to go in and try to solve for d. I can do that by letting x equal 4. If I allow x to equal 4, then these two factors, the x minus 4, cause both of my first two products to be 0. The last product, not 0. So I'd say it's going to be d times 16 plus 16 is where the 32 comes from. 4 plus 4, 8. I'm getting 256 times d is equal to 1. Thus, d is a positive 1 over 256. Now, it's a little bit trickier to find a and b, but not that bad. What I'm noticing is that I don't see an x cubed term on the left-hand side. So I know if I ask you to look at the coefficients of x cubed, we know the coefficient of x cubed, it's supposed to be a 0. There is no x cubed on the left-hand side. Well, how would you get an x cubed term on the right? And the reason I chose x cubed is because I could quickly see b will never equal the coefficient of an x cubed. It can at most equal the coefficient of x squared. But a could be a coefficient of x cubed, c could be a coefficient of x cubed, and d could be a coefficient of x cubed. So I can say the coefficients of x cubed on the right-hand side will be a plus c plus d. I know that that sum has to equal 0. So then I already know c plus d, they're the opposites of one another, so they're just going to cancel out, and thus that gives me a is equal to 0. Now, in order to determine b, I noticed a could never be a constant on the right-hand side, but b could equal a constant. So I said, please look at the constants in the problem. Constant on the left-hand side, it's a 1. On the right-hand side, you would have 4 times -4, so -16b will equal a constant. 16 times -4 is -64c would be a constant. And then 16 times 4, positive 64d would give me a constant. So these are my non-x terms on the right-hand side, my constants. So I already know what c and d are equal to, so I just said, well, 1 is going to equal -16b, and then minus 64 times a -1 over 256 gave me a positive 1/4. 64 times 1 over 256, again, positive 1/4. So I saw that that was just a plus 1/2 on that side. I subtracted 1/2 on each side, and that led me to say 1/2 is equal to a -16b. Thus, when you divide by the -16, you're going to get b is equal to -1 over 32. Now, whenever I go back to my full integral problem, now that I've separated all this last group out, I already knew the first two were very easy. The original u times v gave me this part, and then I knew it was -4 times all of this group. And the first part of that group was the integral of 1 dx. So I have -4 times the integral of 1 dx. That's -4 times x. That's where that came from. But then I had to remember that -4 distributed to everything inside of that integral, so it also distributed to this term right here. So I said -4 times a positive 256. That gave me the -1024 out in front of this group. And now, what's out in front of this group, or what is this -1024 multiplying? It's multiplying the rest of that integral that I couldn't simplify out at this first part, just the x part. So all of this is these three parts. So it's all three of these expanded out in the integral. So you'll notice the first integral is going to be the integral of ax plus b over x squared plus 16. I know A was 0, B was a negative 1 over 32, so I just went ahead and pulled that negative 1 over 32 out in front of that integral and said 1 over x squared plus 16. Then my next one, I have plus C. Well, C was a negative 1 over 256. I pull that out and I have 1 over x plus 4 left over. My D, I had D was a 1 over 256. Yet again, I would just factor that out and say you're just going to be left with a 1 over x plus 4 inside the integral. These last two are super easy because we can just say anytime the derivative of the denominator is in the numerator, it's the natural log of the denominator. This first one's a little bit more complicated, but it's formula number 16 on your table of integrals. 1 over x squared plus a squared is going to equal 1 over a inverse tangent of x over a. You could also use substitution, but that would already make a long problem even longer, so I would just suggest either memorizing or using the formula from the table. It's formula 16 again. So that's what I did from this step to this step. So the first thing I did is I said, well, 1024 divided by 32, and let's see, make sure I did that right. Oh, yeah. So I said 1024 over 32. Oh, and it gave me the 32, so that's where that number came from. Negative times a negative is a positive. But then I said, that just takes care of the coefficient on the integral. Inside that integral, the integral of this portion is going to be the 1/4, since A is 4, a squared is 16, 1/4 inverse tangent of x over 4. That comes from this part. And so now, of course, I'll have to take that 1/4 inverse tangent. That 1/4 needs to multiply the 32 to give me the 8 in the next step. And then in the next one, I distributed this 1024 to each of my other integrals. When I did that, 1024 divided by 256 gave me 4. And the first one, it's a negative times a negative for a positive. Positive 4 natural log of x plus 4. And then I would have minus 4, since it's a negative times a positive, natural log of the absolute value of x minus 4, plus your constant of integration. All I did in this last step was clean up that answer, the 8 inverse tangent that I was talking about just a moment ago. And then the last one, I condensed my two logs. Sometimes Achieve will condense, sometimes they won't. I chose to condense in this case, and it lacked the answer. I could call that 4 natural log of x plus 4 over x minus 4 plus c.